Hi ladies and gentlemen, today we're going to be reviewing state test questions from 2021 and older tests. And these questions are just focusing on the coordinate plane. So how can you use this video? You can pause the video as I start each question, read through the question, test it out on paper, and then unpause it to check the solution to see if you agree. Your strategy may be different from mine, so please don't get too concerned with strategies as long as the solutions are correct. Okay, so we're going to start with number 1 here. We have two vertices of a rectangle. If I draw a rectangle here, let's just talk about the terminology. The vertices are the points where the sides connect, so we have 4 vertices here. All right, so we're told what 2 of the vertices are. We want to know what the distance is between the 2. We practiced this in class. Let's set up one point on top of the other. All right, and we said our second step, we're going to cross out the coordinates that are the same. You're going to notice that the x coordinate here are the same. They're both -5, so we're going to cross those out and only focus on the y coordinates here. And notice the signs are different. That means they're in 2 different quadrants. That means we're going to be adding the absolute values together. So we're going to take the absolute value of 8 and add it with the absolute value of -6. It becomes 8 plus 6, which is 14. So the 2 points are 14 units apart. Question number 2. We've got point W that's located at -2, 3. And we want to reflect it over the x-axis to make W prime. Just shift this up so we have space to work with. All right, so W is at -2, 3. And we're going to reflect it over the x-axis. Well, x-axis reflection means the x stays the same, the x coordinate, and the y value is going to become the opposite. Remember, the first number is x, the second number is y. It's in alphabetical order. So the x, -2, is going to stay the same, and 3, the y coordinate, becomes the opposite. The opposite of +3 is -3. All right, but we're not done yet. Now we're going to take this W prime, the new point we've made, and we're going to reflect it over the y-axis now. All right, in a y-axis reflection, the y stays the same, the y coordinate, and the x becomes the opposite. Again, the -2 is the x, the -3 is the y. So -2 is going to become the opposite. It's going to become +2, and the y coordinate becomes, or not becomes, stays the same, -3. So this new point is called W double prime with the 2 apostrophes. So our coordinates are 2, -3. All right, let's take a look at question number 3. Again, we've got 4 vertices of a rectangle. They're listed here on the side, and we want to know what is the perimeter. So that means we need to find the distance or the length and width of our rectangle. I'm just going to sketch a little rectangle here so we can fill in the information. So let's say this is P, Q, and actually, sorry, doesn't really matter. I'm going to put P on the bottom, Q, R, and S. So let's find the distance between P and Q first. And when we're labeling with the vertices, we always go in order, either clockwise or counterclockwise. All right, so P and Q, I'm going to put those 2 points on top of each other. We're going to ignore the 2 that are the same. So you'll notice the y coordinates are both 2. We're going to cross those out. The 6 and 2 have the same sign. And if you remember the notes from class, same sign means we're going to subtract the absolute values. So absolute value of 6 minus the absolute value of 2. That's 6 minus 2, which is 4. So the distance between P and Q is 4. All right, now let's look at the distance between Q and R. So 6, 2, and 6, 5. All right, we're going to look at the coordinates that are the same. That's the x coordinates, cross them out. Now we can focus on the y coordinates, 5 and 2. Again, they're the same sign, so we're going to subtract the absolute values. I'm going to put the larger absolute value first so we don't end up with a negative number. 5 minus 2 becomes 3. So the distance between Q and R is 3. Now, since this is a rectangle, I know opposite sides are equal. So if the distance from P to Q is 4, S to R must also be 4. If the distance from R to Q is 3, S to P must also be 3. Now we're going to add up all 4 sides. 3 plus 4 plus 3 plus 4. That's 7 plus 7, which is 14. So I didn't need to find the distance between R and S and P again. We know opposite sides of our rectangle are equal, and we can just fill that in. All right, let's go to number 4 here. So Mark has plotted here the school and the bank on the coordinate plane, and the distance from the library to the school is the same as the distance from the bank to the school. Well, let's count out how far the bank to the school is. 1, 2, 3, 4 units. So the school to the bank is 4 units long. That means the distance from the library to the school must also be 4 units long. So let's plot these points and see which one has a distance of 4 as well. All right, 2, 4, 2 to the right and 4 up. That's the same location as the school. No good. That would be a distance of 0. So point A doesn't work. Let's try 2, 8, 2 to the right and 8 up. 1, 2, 3, 4. That does have a distance of 4. So point B is appropriate. I'm just going to double check that none of the other options work here. So if I go to 4, 4, 4 to the right and 4 up, this is a distance of 2. That doesn't work. We need a distance of 4. And 6, 8, 6 to the right and 8 up. While we're looking for the distance from the school to the library, we can't calculate this diagonal distance here, so point D is also not appropriate. All right, let's go to question number 5. Point G and point H are the same distance from point F. Which coordinates could be the location of point H? All right, so let's plot point H. We'll try all 4 of these and see what works. So 1 to the right and 2 up. That's here. If this were H, point H and F would be 2 units, and F to G is more than 2 units, right? This diagonal has a longer distance than the horizontal line. So A is not an option. They don't have the same distance. All right, 4, 2, 4 to the right and 2 up. All right, this has a distance of 1. F to G has a distance. Ooh, I think I'm looking at this incorrectly. Sorry, I'm going to take a step back for a second. G and H have the same distance to F. Yeah. I was correct in saying my first explanation for that first point was good. And then I started mentally going through the next point. It didn't work. So let me just explain that. 4, 2, I'm going up. That would be H. F to H is 1 unit long. And G to H is 2 units. Sorry, G to F. I keep making that wrong comparison in my head. F to H is 1 unit. And G to F is more than 2 units, is 2 diagonal units. So they don't have the same distance. This point is not appropriate. Okay, let's go to 5, 1. 5 to the right and 1 up. 5 to the right and 1 up. This would be point H. So the distance from F to G is this diagonal here. And F to H is also that similar diagonal. Those 2 distances look the same. So far I would say C is the best option. Now let's plot 2, 5 and make sure 2, 5 is not good. So 2 to the right and 5 up. And we're comparing the distance from H to F. That's 3 diagonal units. G to F is 2 diagonal units. So this is not the same distance either, not appropriate. So it is choice C. All right, let's go to number 6 here. We're going to plot all of these points. We want to know which of these polygons is created when we plot all 4 points. So let's start with the negative 5, 5. Negative 5, 5 means we're going to go left 5 and up 5 from the origin. All right, that's this point. In option B, 5 to the left, 5 up is this point. Option C, 5 to the left, 5 up would be this point. Option D, 5 to the left, 5 up is this point. So they all have the same first coordinate here, negative 5, 5. Let's go to 2, 4. 2 to the right and 4 up. All right, in option A, 2 to the right and 4 up is this point. Option B, 2 to the right, 4 up. That point is there. Option C, 2 to the right, 4 up is not there. So we can cross out option C. D, 2 to the right, 4 up. There's no point there. We can cross out option D as well. Okay, let's go on to 6, negative 2. 6 to the right and 2 down. Option A, 6 to the right, 2 down. There is a point there. Option B, 6 to the right, 2 down. There's a point there as well. So now we're going to go to the last point, negative 3, negative 6. So we're going to go 3 to the left and 6 down. Option A, 3 to the left and 6 down. There is a point there. For option B, 3 to the left and 6 down, there is no point there. So it is not option B, it is option A. All right, our last question here. Number 7, we have these 4 vertices of a triangle. Again, vertices of a triangle are where the points, the line segments meet. That's called a vertice. So we want to know what's the distance connecting point A and point B, vertex A and vertex B. So let's line them up one on top of each other. 1, negative 1 for A, and B, 1, positive 4. All right, our x coordinates are the same. We're going to cross them out. And for B, they are different signs. So we're going to be adding the absolute values. So the absolute value of 4 plus the absolute value of negative 1. So 4 plus 1 gives us 5. The distance is 5. All right, if you have any questions, you can email me, message me through Google Classroom, or we can talk in class. Have a good day.